Hello and welcome. I'm Joanna Junak, and in this episode we are opening a new science series. Today, Roberto Sussman, a full-time senior researcher and lecturer at the Institute for Nuclear Sciences of the National University of Mexico, will tell us more about how vapes work and what's really in the aerosol they produce. Roberto, can you explain to us what an aerosol is, how aerosols are created, and what makes them different from one another?
Well, the simplest there's a dictionary definition of an aerosol. It is a substrate of particles that can be solid or liquid that are suspended in a gas, suspended and transported by a gas. This is an extremely wide definition because it can fit many systems, like, for example, fog or fire, not fire, but smoke in a chimney, or a sandstorm, or a volcanic eruption, or the exhaust from a car, and the sprays that you use for either for inhalation or to odorize, these are aerosols as well. And when you boil water for tea, these clouds that is coming out from the spout of the kettle, that's another aerosol. So it is an extremely wide definition. Okay, this is aerosol. So what makes them different? The particles, because a particle has physical properties, has chemical composition, can be liquid, can be solid, and also the gas, because it can be very different gases, like can be air, can be any other gas, a volatile carbon monoxide, a mixture of gases. And so once you see the variety of the type of particles and the type of gases, then it is an enormous amount of systems that we meet every day. Some of them are natural, like clouds are natural, but for example, smoke from a chimney, this is made by humans. So we call them anthropogenic aerosols, and then also the particles can also be biological. They can be bacteria, they can be fungus, they can be virus, and that's another dimension, and these are called bioaerosols, right? So I think this more or less answers how they are formed by many processes. For example, all smokes are formed by combustion, right? Even the combustion it's not necessarily that you go with a match and light it. Like, it can be internal combustion, like in a motor vehicle, or it can be fire through ignition. And they can also be formed mechanically, like the aerosols from the can that you use. They are formed by a process called atomization. It's mechanical. It's essentially a current of air lifting little droplets from a liquid. And this happens at cold temperatures or ambient temperatures. Then you have the aerosol of vaping, that it is produced by heating the liquid, not burning it. There's no combustion. And volcanic eruptions are formed by lava, by the heat of lava. There is melting rocks and throwing little pieces of these rocks and putting them in the air. And then the biological aerosols, they are formed also by air that is flowing through your respiratory tracts, which are essentially aquoid, they are watery, and they are lifting also particles that are essentially made of mucus and some minerals, which basically reduces to water, right? And so there are many, many ways in which they can be formed depending on the type of particles and the gas. There are many processes that can be formed. It is a very wide area of physics and chemistry.
And what is the main difference between tobacco smoke and the aerosol produced by vaping?
Ah, it's more or less the same difference as if you would compare fog and a chimney, right? Both are aerosols, both are visible, but the physical and chemical properties are completely different, right? For example, tobacco smoke is produced by the ignition, like combustion. You actually burn biomatter, that is organic matter. The tobacco leaf is made of organic matter, cellulose, nitrogen compounds, etc. It is a complex structure of about 1,500 compounds, the tobacco leaf. And then when you burn it, burning means that you put immense amount of energy and oxygen. These are the necessary ingredients of combustion. You need oxygen. Oxygen is a very reactive molecule. It always comes O2 and well, the isotopes and so on, but it is a very reactive compound, right? And so you have a lot of reactions. It's a very complicated process, and you have to think that the tobacco cigarette is a small rod of 10 centimeters. Now, when you ignite the tip of the cigarette, the temperatures right in that millimeter, right in that point, is about 900 degrees centigrade. But obviously, the smoker is not going to get 900 degrees in the mouth. It would it would boil the person. No, the tobacco cigarette between the tip of the cigarette to the mouth of the smoker will be cooling the smoke that is produced at 900 degrees. That smoke will be cooled, transported, cooled, so that the smoker will get it at body temperature, around 40 degrees. So you have a enormous amount of physicochemical processes that will absorb this furious amount of energy. Distillation, pyrolysis, pyrosynthesis, there are many, many processes. It's very complicated to explain, but the main effect is that these processes are going to produce a lot of reactions and byproducts because they have to cool an enormous amount of energy. An aerosol that is produced at 900 degrees, they have to transport this and cool it 800 degrees in 10 centimeters. This explains to you the complexity, the chemical complexity of tobacco smoke. Of course, there have been detected 7,000 compounds, but this is not a very illustrative, the number of compounds that are detected is not so illustrative because it depends on the sensitivity of your instruments. Of all these 7,000, we could say that around 1,000, 1,500 are detectable, are detected in significant quantities that are above the threshold. And of those 1,500 compounds, you have 70 identified carcinogens, And you have other that are toxic, maybe not carcinogens, but very toxic, and hydrocarbons, phenols, amines. It's a lot of chemical families of these compounds, right? And so the user is inhaling all this mixture, right? And also we have to mention that smoking is not only what you inhale, but the tip of the cigarette this is a continuous emission. Because even if the smoker is not smoking, the tip of the cigarette is emitting also smoke, right? So this is smoking. Now let's see vaping. Vaping, what you do, you take a liquid, it's a liquid mixture, has solvents, a propylene glycol, a glycerol or vegetable glycerin, nicotine, flavorings, and water. This is the main compounds. You heat that mixture, and what happens is that you generate a vapor, and once you generate this vapor, it is a vapor of that liquid, not water vapor. Be careful, because when people say vapor, they think of a sauna. No, it's not a sauna. It is the vapor of this liquid. Later I will explain in more detail. As the user inhales, it's the same. The smoker inhales and produces this transport. Now, here, the user inhales, but it is inhaling a vapor that was produced between around 200 degrees, between 180 and 290. So, what you have to do is to cool this vapor that was produced at 200 degrees to cool it to 40 degrees. So it is not the same as from 950 to 40, right? And also, because at 200 degrees, the reactions are very weak. You still have reactions, but they're very weak, right? So the number of compounds that are detected, and again, I emphasize that number of detected compounds is just a statement about the instruments. It is between 80 and 150 compounds, of whom about 20 are significant. And of those 20, only 3 or 4 are carcinogen or toxic, the aldehydes, but they're detected in very, very small quantities, right? Because they are byproducts, right? Okay, I will explain with more detail how the aerosol is produced. But now, what I'm trying to say here is an enormous difference. And again, I repeat, in the case of cigarettes, as the smoker inhales, it triggers a lot of physicochemical processes that are going to transport and cool something produced at 900 degrees will have to be cooled at 40 degrees. So it is an enormous chemical complexity. And in the case of vaping, it is not a rod, it is also a rod. The e-cigarettes have like a cylinder where you inhale. So it is a similar process, except that it will start not from 950 degrees, but from around 200, 250 degrees. And of course, the chemical complex, it is much chemical, there is no chemical complexity, there is no mass production of byproducts, only a few byproducts are produced. And this is essentially what the main difference between these two aerosols.
Stay tuned for the next part of our science series in a couple of weeks.